Horizontal curve details. The Runout help files are a useful source of information regarding horizontal and vertical curves. To activate help, press the F1 key and then search for curves. We'll start by opening an existing design file. Choose a layout suitable for horizontal design. The Curve panel allows you to change any curve along the alignment. To move to the curve you want to change, use the Previous and Next Curve button inside the panel. When editing a horizontal curve, the cross-section windows will show the EC, end of curve point. The most common way to define horizontal curves is using a table. It is also possible to define curve parameters manually. Note, curve parameter controls are disabled until a circle or spiral radial button is selected. The relationship between radius, speed design, and superelevation is shown in the following formula, where E equals superelevation percentage, F equals side friction factor, G equals acceleration of gravity, V equals speed, and R equals radius. When checked, Runout calculates the smallest possible curve if radius is auto, the largest possible speed if design speed is auto. Turning off auto for table superelevation allows you to set the super manually. Notice the change to the actual side friction when we change the super. Notice the change to the actual side friction when we change the radius or design speed. The following table shows some typical side friction calculations based on design speed, radius, and super. Changing the super to auto allows us to derive our curve parameters from a table. Look up table for super elevation given radius and design speed. The blank area indicate unsafe combinations. With the minimum radius set, clicking the auto beside the radius and setting the design speed will calculate the minimum safe radius. Increasing the design speed will cause a warning message to appear. Road class specifications are sorted with your template table. Each class of road will have a few typical cross-section templates, a design speed, and other parameters that are common from road to road. If you are using a super elevation table, the parameter in the curve specification most important for horizontal curves is the design speed. Transition length and widening tables are also accessible directly from the curve panel. Road Class Specifications dialog box. The transition length is the distance from half crown to full super, also known as the super elevation runoff. It is labeled length runoff in the figure below. Turn on Auto to set transition lengths using a table. Transition lengths by design speed columns and radius rows. For a circular curve, the super elevation runoff must start before the curve BC and end after. Similarly, at the end of the curve, the transition starts before the EC and ends after. The transition fraction is the amount of transition that happens outside of the curve before BC and after EC. For example, if transition length is 90 feet, if transition fraction is 1.0, the super elevation runoff starts 90 feet before the BC point. The full super elevation is reached at BC. If transition fraction is 0.667, a common standard, the super elevation runoff starts at 60 feet before BC and the full super elevation is reached 30 feet beyond BC. Tangent runout length, distance from the full crown to half crown. Clear the Auto button to set the tangent runout length explicitly. With the Auto set, the tangent runout length is measured as a fraction of the crown slope. The cross-section window is very useful for viewing and checking curve transitions. It allows you to step through curves and watch the crossfall change. Use the next and back buttons in the toolbar, not the curve panel, to move through the reporting points on the curve. The profile window can also be configured to show the super transition.